Hello, everyone. So today we are going to get into 6.4. It's the very last section in Chapter 6 that we're going to do. We actually ended up cutting out a lot of Chapter 6. We kind of boiled it down to the absolute bare bones that you need to know. Um, we had that quiz last week. Hopefully you've taken that. If not, make sure you go in and take it. If you weren't happy with your score, you can go back. You've got 3 attempts on it. So make sure you go back and do that. Get some quiz points in there. We are going to spend the rest of the week on 6.4. We're going to spend Monday and Tuesday on exponential growth and decay, and then Wednesday and Thursday on compound interest. And then next week we'll probably Monday and Tuesday we'll probably take a data review, and then Wednesday and Thursday, depending on if you're A group or B group, is going to be the day that we actually test. So I just want to make sure we feel super confident about everything in this chapter. I want us to make sure we do well on that very last test of the trimester. So just let me know if you're struggling on anything that we've done so far. I know this is a lot different than some of the stuff that we've been doing in the past, so some people takes a little bit longer to kind of understand some of this stuff. So let me know if you're struggling with anything. We're going to move right along. If you have your student journal, we're on page 185. You may need to pause the video and grab some of this vocab if you want to have the definitions here. We're going to be covering compound interest in the next video, but if you just want to grab that definition now, you can. Okay, we're talking about 2 things really today. We're talking about exponential growth, and we're talking about exponential decay. All right, and then we've got all this complex, formula stuff. We'll get more into the formulas later. Don't panic if that doesn't make sense to you yet. That's fine. I'll explain it a little bit later into our notes. Really what I want you to get right now is, what is exponential growth? What is exponential decay? Okay, so exponential growth. Okay, I've got some graph. We start out really, really small, and then it kind of gradually goes up, and then all of a sudden it feels like it shoots up almost out of nowhere. Okay? A lot of things grow like this. If you look at a graph of the population of the Earth, it kind of looks like that. If you've paid any attention to the news in the last 12 months, a lot of viruses look like that. It seems like it's going up maybe a little, and all of a sudden it's almost doubling every day. A lot of different population data looks like this. A lot of science things kind of grow in this way, in exponential growth. Say if you have like a bacteria and every hour it doubles. Okay, again, it'll start by going 2, 4, 6, 8. It wouldn't be 6, huh? It'd be 2, 4, 8, 16. And then all of a sudden it's exploding and it's growing by 1,000, 2,000, 4,000. Okay, so a lot of things in science will grow in this exponential growth pattern. That's why I really actually like this chapter a lot, because it starts to connect some of the math that we're doing with some things that you see in real life. Same thing for exponential decay. I feel like there aren't as many real world examples of the exponential decay. There definitely are some. Exponential decay would be almost, you start really high and then very quickly you kind of level out to a certain value. Examples of exponential decay, it can be a population, like a population of animals. Think something where their habitat's being destroyed and all of a sudden a very large population of some animal goes down to almost nothing. That can be exponential decay. If you've studied, I don't think you guys are in chemistry yet, but there's a thing called isotopes where the matter will go and halve every couple of years, like something like uranium, something radioactive, where it goes down by half every year or every 2 years or whatever it is. That can be an exponential decay where it's going down by a lot, the first year to the second year, and then after a while it kind of levels off where it's still decreasing, but not by that much anymore. Okay, so again, there's two different patterns that we can see. We can see it kind of pretty stable, and then all of a sudden it shoots up in exponential growth, or it very quickly goes down and then it kind of tapers off with exponential decay. So let's look at some of these formulas, because I think where people get tripped up are the formulas for these different things, for exponential growth, for decay. We'll get into them tomorrow with the compound interest. Okay. So I would definitely mark this place in your student journal. Make sure you know where it is. You don't have to memorize this. You just have to understand it. Okay. So we've got this formula. It's our y is equal to, we've got a 1 plus r to the t power. We've got all these lovely little definitions of what all these things are. We see that y is our final amount. Okay, for almost all these problems, you're going to plug in everything else, the r, the t, the a, all this other stuff, and then your answer is going to be that y. What's your population? What's the value? What's the the final number you're solving for y. Okay, a is your initial amount. Okay, so however many you're starting with or whatever your starting value is. R is going to be your rate of growth. So this is the one that we use with exponential growth, if it's growing in value. Okay, so if you see growing, increasing, appreciates, oh, that's not an A, huh? Appreciates. When you see appreciates in a math problem, it's not like I appreciate you doing the dishes. It means appreciates like it's growing up in value. It's the opposite of depreciating, which is going down in value. Okay, so those are all the keywords you're going to see that says, oh, I should be adding my rate to 1. Okay, the rate has got to be in decimal form. It's going to give you a percent. Like over here, it gives you 5%. Okay, we've got to know that 5% in decimal form is not just 5, it's 0.05. You got to move that decimal 2 spaces, okay, to the left. 0.05, that's very important. That's the easiest way to goof these problems up. Okay, so very last bit is our time. That's why this is an exponential. Okay, we're taking it to the t power. So if I say it goes up by this much every week, it's how many weeks. If I say it's every month, it's how many months. A lot of times it's years. Okay, so if it says it goes by this much every year, it's how many years. Okay, so let's put this into action. Okay, I put in a different little problem here. It's not in your student journal, so if you need to pause it and write it down, you can. Right? It says a college tuition of $135 per credit hour increases by 5% each year. All right, 5% each year. So we need to be able to plug everything in. Okay, all this. Oh, I was supposed to erase it. All this stuff over here. Gotta know. Okay, each number. What does that correspond to here in my formula? Okay. I've got my y is equal to a 1 plus r to the t power. Usually, and in this one I'm solving for y, and I need to be able to know, okay, what's a, what's r, what's t? Okay, a is my starting amount. So 135 is the amount that I'm starting with. Okay, that's gonna go there on the outside of my parentheses. Okay, the 1 never changes. 1, it's growth, so I'm going to add. Okay, spoiler alert, if it's decay, you're going to subtract. Okay, it's growing. It's increasing. I know this is a growth problem. Okay, increasing by 5%. So again, 5% is my rate. And I'm going to be very careful. I'm not going to just say 1 plus 5. I'm going to get a crazy high number if I do 1 plus 5. I have to remember that 5% is the same thing as 0.05. You gotta scooch that decimal 2 spaces to the left. Okay, 1 plus 0.05 to the t power. T is just going to stay t because I don't know how many years yet. Okay, I can simplify this. If it's asking for an equation, I can say, well, I know that 1 plus 0.05 is 1.05. I can combine those. Still to the t power. Again, don't fall into the trap. Don't multiply 1.05 by 135. Okay, you're always taking it to that exponent first. Then you would multiply it by 135. Okay, so usually it wants the actual formula, and then it wants, okay, well, how much is tuition after 4 years? So let's plug in a number for t and solve it out. Okay, so y is equal to, got 135, got 1.05 to the t power. Okay, so t is going to be 4. Okay, so it said every year, and I've got 4 years, and I'm plugging in 4 for t. Now I can pull up my calculator. Okay, I can even show you guys how I do this. All right, so again, first thing that I want to do, I want to take 1.05. I want to make sure you can actually see it. 1.05 to the 4th power. Okay, so your calculator probably has something similar. I have this y to the n button. You might have an x to the y button or y to the x or something similar. Okay, that's kind of like your exponent button. Okay, you can hit that. Then your exponent, it gives me this value. Okay, I can write it out just so I kind of see what my step is. For these, I know you're doing this in the calculator, so as long as you at least give me what you started with in your final answer, I know that you're doing the actual math in your calculator. That's fine. Okay, so I'm going to say y. That's not cooperating with me for some reason. That's fine. Okay, I don't know why it's doing that. Let's just go back to the calculator. I've got that 1.05 to the 4th power. And I know I need to multiply that by 135. Okay, so times 135. Awesome. Okay, so 164. I don't think it says how to round it off. So it's a monetary value. So I'll say 164 and 9 cents. I'll just go to 2 decimal places here. 164.09. And I hope when I go back to my other tab, it is going to let me write again. Okay, so y is going to be equal to, there we go, 164 and 9 cents. 164 and 9 cents for that final answer. Okay? So that's for growth. We've got a very similar process for a decay problem, except it's going to be subtraction there with that rate. Let me show you what I mean. Okay, on that very next page, it goes into exponential decay. Okay, so very similar formula here. All right, my final amount is equal to my initial amount, except instead of 1 plus r, it's 1 minus r. Okay, I'm not going to get 1.05, I'm going to get 0.95. 1 minus the rate, then take it to that power the time. Again, everything else is the same, but with decay, it's not increasing, it's decreasing. Okay, so it is subtracting. Let me give you some words like I did before. What did I do last time? Growing, okay. So shrinking, decreasing, depreciates, or depreciating. Okay, all of those are key words for exponential decay. Those should all set off an alarm bell saying, oh, I need to subtract for this one. I'm not going to add. All right, that's probably one of the biggest ways that people mess up on these problems. They plug everything else in correctly, they do all the other math right, but they forget that they should subtract the rate instead of add the rate. So just be very careful with that. Okay, so we have our first one. Let's come up with our equation first. So a $25,000 car decreases by 16.7% each year. Okay, my final amount, I don't know yet. That's what I'm going to solve for. It starts at that value, that $25,000 value. Okay, I've got 1 minus r. Okay, 1 minus, and I'm not going to say 1 minus 16.7%. I'm going to get some crazy number if I do that. I know I've got to move that decimal place to get 0.167. Okay, to the t power. All right, and then for my final, I do want to simplify that. Okay, so I've got 25,000 and then 0.833. Okay, we call that your decay factor after you take 1 and subtract the rate. Okay, all to the t power. So now it's ready to plug in. This one happens to be 4 years again. I don't know why I kept picking 4. Okay, so same deal. I'm going to plug everything in. 25,000 and then 0.833 to the 4th power. All right. So I don't want to switch tabs again because I think my computer didn't like it when I switched to the calculator. I am just going to go, okay, 0.833. I'm going to hit my exponent button again. It also might look like a little caret. So I'll try and draw this. There might be a button on your calculator that looks like that. That is an exponent button. Okay, if you can't find it, look for a button that looks like that. Right. 833 to the 4th power. Okay, I get 0.48 and then a big long decimal. I'm going to multiply that by 25,000. I get, that's the eraser. I get $12,037. I'm going to go to the nearest cent, 0.05. So I get 12,037. And I get 0.05 and 5 cents. Okay, so cars are one of the biggest things. If you get an example of something that depreciates, it's always going to give you a car because that's kind of infamous for losing value the longer that you own a car. You're almost never going to sell a car for more than you bought it, unless it's maybe like a classic, you fixed it up or something. Okay, so after 4 years, this car is already at about half of its value that you bought it for. Okay. Again, the biggest thing to remember, make sure that you know these formulas, you know where to find them. I'd probably put this up at the top of your homework. I think actually it's printed on the top of your homework. Okay? Just remember for growth, you're always adding your rate, and for decay, you're subtracting it. Okay? You have the day 1 homework. That's all these growth and decay problems together. Go ahead and get started on that, and I will see you guys later.